quick note of caution before we proceed. You'll see that I often refer to the decimal point being moved. Again, the decimal point being moved to the right, the decimal point being moved to the left. Technically speaking, guys, this is not quite correct. The digits move. However, for the sake of simplicity, I will simply refer to the decimal point being moved. To convert from ordinary form to scientific notation, we will follow these 4 steps. Now first you have to understand 520,000 is exactly the same as 520,000.0. Now we can perform step number 1. Place the decimal point after the first non-zero digit. Our first non-zero digit is 5. We can see the value of A already. The value of A is that part, 5.2. 5.2 is the A component. Next, we need to work out the power part. So step 2, count the number of places the decimal point moves. So it has gone 1, 2, 3, 4, 5. Step 3, if moved to the right, the exponent is negative. If moved to the left, it's positive. So I know that my base is 10. It's moved to the left 5 places, and it is a positive 5. Let's try the next one. First, we need to understand that that is exactly the same as 980,160,000.0. It's the same number. Step number 1, place the decimal point after the first non-zero digit. First non-zero digit is the 9. My A component is that part of my number. So I can write that in already. I've got my A as. Now I need to work out the power component. How many places has the decimal point moved? 1, 2, 3, 4, 5, 6, 7, 8. So it is base 10 to the positive 8. Here's my final answer. Next number. We have a very small value. Step number 1, put our new decimal point after the 3. A component is 3.4, so I can write my 3.4. Next, I have to work out the power component. How many places has the decimal point moved? 1, 2, 3, 4. 4 to the right. That means it is 10 to the power of negative 4 because it is moved to the right. And there is my final answer. Last example. Step 1. There, I put it after the 6. Now we can already see the A component, 6.75. Now I need to work out the power. The decimal point has moved. 1, 2, 3, 4, 5, 6, 7. 7 places to the right. So I have 10 to the negative 7. So what we'll notice with these examples is, if you ever have a really large number, the exponent of the power is positive. If you have a very small number, the exponent of the power is negative. Progress check. Have a go yourselves, then check your answers with mine. Step 1. Place the decimal point after the first non-zero digit. So we are moving the decimal. We can put it over here. Our A component for scientific notation has these digits. Now we need to work out the power. How far has the decimal point moved? 1, 2, 3, 4, 5. It has moved 5 places to the left. And there's our solution. Next up, we have an incredibly huge number. Well, that is exactly the same as this value that you can see with the 0.0. Now, step 1. So I can place it over here. There we have our A component for scientific notation. Now, step 2. Count the number of places the decimal point moved. 1, 2, 3, 4, 5, 6, 7, 8, 9. It moved to the left, so we know that that will be a positive 9. And there is our final solution. Next up, again we follow our steps. Place the decimal point after the first non-zero digit. So let's put them over here. There is our A component. Now we need to work out the power. 1, 2, 3. 3 places to the right. The base is 10. And 3 places to the right means it is -3. Last example. This is a really small number. So place the decimal point after the first non-zero digit. That is a 9. Already we can see our A component. There it is in yellow. Now we need to work out the power component. 1, 2, 3, 4, 5, 6 places. So we have times 10 to the -6. The decimal point moved to the right. And that is a wrap, guys. We simply follow these 4 steps and we'll get the correct scientific notation every time. Hey guys, this is Casey at Onetree. If you like the content, please remember to like and subscribe. Also, if you'd like some online tutoring, please email me at onetreemath@gmail.com. Cheers.